Yes, it's still degree 2. Yes, yes. Okay. First coefficient 1. Second coefficient 4. Last coefficient 7. In the correct order, be very careful here. Good, I want to solve. Aha! Wonderful. What does that mean? It means, and we can do this also. We can say, oh, what does that mean? Okay, let's graph this function. You'll see it will never touch the x-axis, and it's always positive. So in y equals, I plug in x squared plus 4x and plus 7. And I use the standard viewing window. We hope that it's there. I don't know. Aha! It's always positive. It never touches the x-axis as expected. Fine. Excellent. Where I did not share my screen. Okay, let me start from scratch. So in apps, we choose number 9. It's a polynomial. Enter. It's already there because we used it before some time ago. Degree 2, yes, indeed, degree 2. It's asking me to put in these coefficients in the correct order, 1, 4, and 7. And then it's asking, oh, then I really want to, to get the roots, the solutions of the equation. There are no solutions, no real solutions found. So the equation has no solutions. Then what I did, I went to y equals, and I plugged it in, and then I graphed it. I want to see, that's why. It never touches the x-axis, it's always positive. That's why there are no solutions. So I come back to my note and I'll say none. No critical numbers coming from this source. So the function has only one critical number. It needs to be investigated. G prime, g of x. Since this is never 0, it's always positive. The function has all real numbers as domain. The only number that I'm interested in is this. The derivative is 0. All I need to do now for the derivative, plug in a number to the left of -2, plug in a number to the right of -2, and find the sign. Eventually, I will plug in the function -2 and find the y value for -2. So here's one way. We can plug this function, but there is no need to plug in the denominator because we already looked at it. It's always positive. It would be a waste of time to plug in numbers in the denominator. We just graphed it. We looked at it. It's always positive. I don't want to waste my time with that. So just in 2x plus 4, plug in a number to the left of -2. No numbers, just give me the sign. And then in 2x plus 4, plug in a number to the right of -2, like the easiest one will be 0, and give me the sign. What is the sign here?
Minus.
Very good, awesome. And what is the sign here?
Very positive.
Very good. So we expect the function to do this because the derivative is negative, and we expect it to do this because the derivative is positive. Now I have to find the point. So in the function, in the natural log, right here, I'm going to insert, that's how lazy people do it, because that's what I have. So I didn't want to type it up again, so it was natural log of x squared plus 4x plus 7. All I need to do to determine the y value of that point is plug in -2. Okay, got it. So it's 1.1 approximately. Good. Now we will say this. Yes, this function has a critical number, and and this critical number is a point of extrema, or a point of extremum. What type of point is it? What should I write under -2, 1, 1.1, like here?
Local.
Very good. Local or relative min. Excellent. That's it. That's all we need to do. I'm going to share my screen so we can look at a word problem now. You choose. Optimizing revenue. Optimization means finding max min to optimize. Solar eclipse, you choose. Let's see on the next page. Temperature during an illness. Anything that you are interested in, you choose. Revenue, yield, solar eclipse, or temperature.
Mine says 68.
Somebody says 68.
Okay, very good. Let's take a look at 68. Optimizing revenue. Oh, okay. So a software developer notices that the number Y of downloads of an app, so this is 68, in thousands. Okay, Y thousands. Is related to the price P, or price X in dollars. Fine. Y equals, so Y of X equals 2.6 minus 0.4X. Okay, find R of X, part A, R of X, the total revenue generated with the price of the app being X. Okay. So this is the number of downloads for the price of X. So let's create the revenue. So how do we get the revenue? Any suggestions on the revenue? So X for each 1,000 of downloads. Let's look again to make sure. It says in 1,000. Okay, so dollars of the app buy. Okay. Good. So how do we get the revenue? Obviously, X times Y. So when I distribute here in the correct order, -0.4x squared plus 2.6x. X times -0.4x is this. X times 2.6 is this. So we determine the revenue. Number of units times the price per unit. Find the relative max, min, or relative extremum of R and interpret this result. Okay. So I'm asked to find if this function has max, min. How do I start? What is my next step? What am I looking for?
Differentiate.
Yes. So I'm looking for, in part B, look for critical number or numbers. If there are no critical numbers, no points of extremum or point of extrema. Good. So R prime of X. Can anyone give us the derivative?
.8
Minus 8.
plus 2.6.
Should we look for R prime being undefined?
No.
No, because this is a polynomial function. None. Should we look for R prime being 0? Yes, of course. -0.8x equals -2.6. So x is 26/8. This is the critical number. We can divide 26 divided by 8. 3.25 dollars. Now, this is the critical number, and the only critical number that this function has. Is this a max min? No clue. I have no idea. Well, I do because it's a quadratic function, but let's say we don't. I have no idea. I create my table, x, because x is price. I cannot say negative infinity, although this is correct. It's a polynomial function, right? Where's my, it's a polynomial function, it's defined everywhere, but since x is a price, it has to start at 0 to infinity this time. First, I have to put in my derivative, and then the function. The only number that I have is 3.25. I know what happens at 3.25 for r prime. I don't know what happens for r, but in a moment I will. So here is my derivative. I have to find the sign to the left of the critical number and the sign to the right of the critical number. What if both signs are positive? What type of point is this if both sides are positive?
Minimum.
Both sides positive.
Does not,
No
max.
critical number if both sides are positive. What if both sides are negative?
No critical number.
No critical number. And we know only if it changes sign, then we will investigate the type. Awesome. So in this function, plug in, let's say 0, that's the easiest. And in this function, let's say plug in 10. And just give me the sign. I don't care for the number, just the sign.
Positive.
So on this side is positive, and on this side,
Negative.
negative. Now I know that the function is doing what here between 0 and 3.25?
Going up.
Very good. What about here? Between this and whatever, that's not possible. You know what I mean. The price cannot be infinity, but
Down.
good. When I find the y value, which I will in a minute, what type of point is this?
A max.
Yes, a relative or local max. Very good. Awesome. Now in the function, I have to put the function in, this function, and plug in 3.25 to get the revenue. So in y equals, or if it, because it's just one number, we can do it the way I don't like to do it, but that's okay, because I understand why. Some students say, but it's just one number. I understand, it's true. 3.25 I square and plus 2.6 and multiply by 3.25. See, it's so much easier for me to just plug it in later, but that's fine. Okay, 4.225, but this is in thousands, right? So this is 4.225. But since y was in thousands, y in thousands, we didn't determine the thousands, so that's all it is, 4.225 for thousands. Yep. Any questions?